Why? Why? Oh, I forgot I was making the math video. I was just overcome with emotion. I at least have the math video to look forward to. I was just thinking about the game yesterday and I just was back in that place. We just lost by 1 point. Okay, Miss Counters, pull yourself together. It's time for lesson 5. Guess what? We're modeling. Feeling better already talking about this. And now, instead of adding, we're going to be subtracting. Here goes nothing. We are getting into lesson 5. I have some former 5th grade mathematicians in the room with me for a little visit. Do you guys want to say hi?
Hi!
So they are taking a walk down memory lane. This was their classroom last year. They're looking at their old desk. It's just a screen. No, you can't. No. It's just screen recording. It's just audio. So if you hear any 6th grade sounds, that's what's going on. Okay, you guys. So in lesson 5, as I told you, we are doing subtraction. We are continuing to model. I'm continuing to work on having 2 rectangles that are the same size. We are going to continue doing columns for our first fraction and rows for our second. So here we're looking at 1/3 minus 1/4. So I'm going to go ahead and show 1/3. This should be pretty E-word by now. So I have 1/3. And then here I'm going to show 1/4. And I'm going to shade in one of my 4 rows, 1/4. And now what we need to do is we need to find a common denominator. 3 and 4, as you guys know, are not the same number. We cannot subtract here until we have a common denominator. So I'm going to, okay, so we did columns, rows for 1/3. And we're going to do RC, rows, columns for 1/4. We've done our columns for 1/3. We've done here our rows for 1/4. Now I need to put fourths on top of our thirds. I need to put 4 rows on top of our 3 columns. Okay, check. Also, I need to put, so we've done our rows here. Now we need to put 3 columns on top of our rows. What we've shown here, you guys, is our common denominator. Before we had 3 columns, now we have 3, 6, 9, 12 boxes. How many boxes are shaded out of our 12? 4. We've just shown that 1/3 is equal to 4/12. Here, we've also divided this rectangle into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. No longer is 1/4 shaded. Now we have 1, 2, 3 shaded. So we've just shown that 1/3 is equal to 4/12. 1/4 is equal to 3/12. Now let's go ahead and rewrite our expression with our common denominator. Denominators, I suppose. So now we're looking, instead of 1/3 minus 1/4, we're looking at 4/12 minus, 3/12. And I think you guys can check that out pretty easily. 4 minus 3 is 1. So 4/12 minus 3/12 is 1/12. What I would like for you guys to also do, well, not like, what I'm ordering, demanding you guys to do within these is, as well, is to show the subtraction. So here we have 4/12. We're taking away 3/12. I really do need you guys to model the taking away of 1, 2, 3/12. And as you can see, just as we did in our expression right above there, we have 1/12 left over right here. Cool beans. Bye, buddy. Love you. I'll see you soon. Okay, let's take a look at this one here, you guys. Bye, buds. Let's look at 2/3 minus 1/2. We'll go ahead and change our colors. We're going to model columns and rows. We're going to model just as we have been CR for our first fraction, and then RC for our second, meaning columns first and then rows. For our second fraction, rows then columns. So it all starts with 2 rectangles. So I need to show 2/3 here. We're going to show that using columns. So I have 1, 2, 3 columns, and now I'm going to shade, oops, I got a little messy there. I'm going to shade 2 out of our 3 boxes. Let me clean that up a little. Oops. We have 2 out of our 3 columns shaded. Clean that up. And here we're going to show halves. We need 2 rows because our denominator is 2, 1, 2. And I'm going to shade 1 of our 2 rows because that fraction is 1/2. Cool. So here we have 2/3. And then here we have 1/2. So I've done my columns for 2/3. I've done my rows for 1/2. Now we need to lay halves onto our thirds using rows. And now I'm going to lay columns, 3 columns onto our 2 rows. The reason we're doing this is that we're showing a common denominator. So no longer do we have 2/3 shaded. Now we have 1, 2, 3, 4 shaded boxes out of 6. 2/3 is equal to 4/6. Here we had 1/2. No longer do we have 1/2. Now we have 3 out of 6 shaded. So now let's go ahead and rewrite our expression. 2/3 is equal to 4/6. So our expression now is 4/6 minus 4/6 minus 3/6. Those are our common denominators. 4 minus 3 is 1. So 4/3 minus 3/6 is 1/6. I think that is pretty simple. Let's show that in the model. So here we have 4/6. We're going to model taking away 3/6. So 1, 2, 3, 6 taken away. And as you guys can see in our model, we have 1/6 remaining. This is what we're left with. Our difference. So we have 1/6 remaining. Bye, buddies. Bye, bye, bye. Come see me. Bye. Keep being awesome. Okay, love. Okay, cool. Come back, guys. Love you. Okay, all the 6th graders are gone. I hope this is really making sense. It's very straightforward, super visual. Let's take a look at one more here, guys. Okay, buddies, I chose a word problem here that will involve some subtraction with fractions. Let's go ahead and recall our strategies for word problems. Read, draw, write. Okay, so let's go ahead and read. Robin, oh, this is actually not Robin. This is Vanya. Vanya has been doing some baking. Vanya used 1/4 of a pound of butter to make a cake. Hooray. Before she started, she had 7/8 of a pound of butter. How much butter did she have when she was done baking? Give your action as a fraction of a pound. Okay, great. So let's just think about, let's just draw. Let's just make sense of this in terms of butter. So I'm going to draw a stick of butter. She used, okay, so before she started, let's go ahead and mark how much butter. So before she started, she had 7/8 of a pound. Okay, so before she started, she had 7/8 of a pound. Let's go ahead and maybe pretend like this is not there. So before she started, she had this much butter, 7/8 of a pound of butter. She made a cake, and I hope she's going to bring over the some of that cake to share with us. From the 7/8 of the butter, 7/8 of a pound, she used 1/4 of a pound to make the cake. So let's just, and of course this is not proportional. Let's just imagine her cutting off 1/4 of a pound from her 7/8. So what we are looking for is if this entire stick of butter was originally 7/8 of a pound, and she used 1/4 of a pound, what was she left with once she was finished baking? And I think the way that I drew this is probably a little bit misleading, completely accidental, but I'm going to try to erase the way that I had this labeled. So let's think about it like this, you guys. So this entire stick of butter was 7/8 of a pound. She cut off 1/4 and she used it for a cake. How much butter does she have left? Meaning she wants to have a bagel with butter in the morning. Does she have enough? How much butter does she have available for that bagel with butter? So this is going to be an expression that I think a lot of you are already thinking about. This is going to look like 7/8 minus 1/4. And our answer is going to give us, the difference between these two numbers is going to give us the number that is left over in terms of how many pounds of butter. You guys immediately recognize that those denominators are not the same, so we cannot subtract these fractions until we have a common denominator. The way that we're going to find a common denominator is by modeling. Keep in mind, friends, we're not looking for the lowest. We're not looking for the least common denominator. We're not looking for any specific common denominator. We're just looking for a common denominator. We're just looking for a representation, an equivalent fraction to each of these that is the same. We're just looking to convert 7/8 and 1/4 into equivalent fractions that happen to have the same denominators. And this is how we do that. We're going to show 7/8 first, and our first model is going to be columns. So I'm going to draw 8 columns, and I'm going to try to draw nice straight lines. So I have 1, 2, 3, 4, 6, 7, 8. Is that 8? 2, 4, oops. 1, 2, 3, 4, 5, 6, 7. Yeah, 8. I'm going to shade in, so I have 8 columns. I'm going to shade in 7 of my 8 columns because I'm representing, in this model, 7/8. 7/8. Our second model is comprised of rows. I'm going to draw 4 rows because this fraction is 1/4. The denominator is 4, so we have 4 rows. And we're going to shade one of those rows to model 1/4. Okay. So we have CR, and then we have RC. So I've done my columns for 7/8. I've done my rows for 1/4. Now what we're going to do is lay our rows on top of, our 4 rows on top of our 1/8. Beautiful. And next I'm going to lay our 7 columns on top of our 4ths. Our 8 columns. Wish me luck. 1, 2, 3, 4, 5, 6, beautiful, 7 and 8. We now have equivalent fractions. No longer do we have 7/8 shaded. Now we have 1, 2, 3, 4, 5, 6, 7 times 4, 28. Nope, that can't be right. 1, 2, 3, 4, 5, is that right? 1, stick with me here, guys. Yeah, that's right. 7 times 4. Now we have 28 out of how many boxes is this rectangle broken up into? Well, it should be broken up into 1, 2, 3, 4, 5, 6, 7, 8 by 4, which is 32. Holy moly. So now our shaded portion is represented by 28 32nds. Over here, 1/4 is now equal to 1, 2, 3, 4, 5, 6, 7, 8. 30 seconds. I know that the denominators are the same because here we have an 8. We have 8 columns by 4 rows, 32. Okay, so now we can rewrite our expression. 7/8 we have determined is equal to 28 30-seconds. So let's rewrite our expression so that we can evaluate this. So we have 28 30-seconds. We've found that 1/4 is equal to 8 30-seconds. So now we have 28 30-seconds minus 8 30-seconds. 28 minus 8 is 20. So what we're looking at here, you guys, in terms of our final difference is 20 30-seconds. Beautiful. We are going to show that subtraction on our model. So here with our 28 30-seconds, we are taking away 8 30-seconds. So I'm going to cross out 1, 2. I'm showing the subtraction here on the model. This is the big difference, of course, between addition and subtraction. We actually have to show the removal of the 8 30-seconds. So that's 4 30-seconds, represented by these x's, 5, 6, 7, 8. So I've shown you 8 30-seconds. What we're left with is the shaded region. And we're going to count these up and hope that these are 20 30-seconds. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, I love counting, 16, 17, 18, 19, woohoo! 20 30-seconds indeed is our final answer. Hope you guys are enjoying the subtraction as much as I am. Our secret word of the night is, what did our very sweet Vanya make in this word problem? What did our very sweet Vanya make in our word problem? Can't wait for more fun tomorrow. I will see you guys in the morning.